You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com. And be sure to follow us on Facebook. Here's what's coming up next.
All right, fourth graders, welcome back. It's Mr. Nick. We're ready for week 3, day 4. So if you look at your very first problem, you got this rows and diagonals problem. So this thing here. And so when we look at our directions, it say complete each multiplication puzzle, find all the products of the rows and the diagonals. So what I have up here is the example for us, which is kind of already done for you, but I just want to show you how this works. So if I multiply across here, here, and here, this row is going to be the product. Or if I go diagonally here, the product of these 3 factors will be 80. If I go here, the product of those 3 factors will be 35. So if I start simply, if I think 7 times 5 is 35, what number will give me 35? That one's pretty easy. Now going across here, some number times 6 times 1 equals 48. What number times 6 times 1 is 6? What number times 6 equals 48? 8. Excuse me. 3 times 5 times 3. 3 times 5 is 15. 15 times 3 is 45, or I can use the associative property, and 3 times 3 is 9, 9 times 5 is 45. So no matter what, we're getting 45 there. 7 times 4 is 28 times some number is 56, and that same number, 8 times 5 times some number, has to equal 80. So 7 times 4 is 28. 28 times 2, maybe I don't want to do that in my head. So maybe 30 times 2 is 60. So take off 2 of those. That's going to work for 56. So does that work for 80 as well? 8 times 5 is 40. 40 times 2 is 80. So you have 2 of those to do on your own. You're going to try to figure out what the missing factor is and work diagonally across this way and make sure it works every single way. Try out some numbers, try out some factors, see what comes of it. All right, the next one for today is a puzzle. I'm not going to do, you have some guys walking, some guys playing golf. It looks like a girl playing volleyball. We're going to do a different one. So I don't want to steal that thinking from you as always. So we're just going to do a different one. I use circles and triangles and squares for mine. So all 3 of these circles added together equals 27. So they all have to be the exact same number. What number 3 times, added 3 times together, equals 27? Let's try some numbers. 5 plus 5 plus 5, 15, too small. 10 plus 10 plus 10. 30 too big, but not too far off. If I take one of those off for each one, 9 plus 9 plus 9, or 9 times 3, is 27. That means all of my circles are going to have the value of 9. Now we're down to row 2. And now row 2 has something special that's going on. It has multiplication and addition. What we have to do here first is we have to do our multiplication before we do our addition. So I need to find 9 times some number plus that number equals 70. So let's do the same guess and check kind of idea. If I do 9 times 10, that would be 90. 90 plus 10, that would have to be 100. That doesn't work. Let's try 5. 9 times 5 is 45, plus 5 is 50. That doesn't work. So we know right there it's somewhere between 5 and 10. If I take 9 times 8, 72. 72 plus 8 would be 80. What about 9 times 7 is 63, plus 3 or plus 7 is 70. So we're going to go with 7. 9 times 7 is 63, plus 7 is 70. So now all of these triangles are 7. Moving on, same idea here. We have to multiply first. So 7 times 7 is 49, plus some number equals 54. That number is 5. So all of the squares are 5. So now, again, I see multiplication. So I have to do, there's 2 5s there, and we're going to go with 10, 18. So 18 times 10 plus 7. 18 times 10, 180. Plus 7, the question mark equals 187. Now we've done a lot of these like puzzles through the past few weeks. I want you to look at the math that you're doing while you're trying to figure this out. So if I say I'll make the triangle be the triangle, just I'm going to give it a variable A. I'm going to make the circles B and the squares C. So what you're really doing here is you're solving something that looks like A plus 2B times 2C equals, and we'll even call it X. So in 4th grade, you're already doing this complex type of mathematics that we think about only the middle schoolers or the high schoolers doing, and you're doing this already in 4th grade. That's pretty impressive. Our last thing for today is looking at area and perimeter. So we've done a lot of area and perimeter problems through the past few weeks. So the first one on here today says 49, and we're going to review kind of what perimeter is and what area is. So it says you have a rectangle that's 49 units. And 38 units. We've done so much math the past few weeks that it would be one thing to kind of figure, we could figure out the area just by multiplying and do the regular algorithm. But if I look at these numbers here, what's 49 close to? 49's kind of close to 50, and then 50 is kind of close to 100. So if I think about this as 100 for area equals 100 units by 38 units, that would kind of make it look like twice as big, but I only want part of it and then a little bit more less off. So I know I can do this in my head. 38 hundredths. 100 square units, but I don't want all of that. I want a little less than half of that. So half of 38 hundredths. What do we think that is? That's about 1900 square units. So now as I do this, as I actually try to solve this, I know that I already have an estimate. My answers should be a little bit less than 1900 square units. Now we can actually use some of those area models that we used in the past. So I can do 40 plus 9 and 30 plus 8. Sorry about that. So I could go 40, same idea here, 40 and 9, 30 and 8. So when I do 40 times 30, I get about 1,200 square, or exactly 1,200 square units there. 30 units by 9 units, 270 square units. 40 times 8, 320 square units. And then 9 times 8, 72 square units. Now I'm going to add all of these up, and my answer we know should be close to 1,900. 1,200 plus 320 plus 270 plus 72, 2, 14, 16, 1, 3, 6, 8, plus one more, 1,862 square units. Look at the difference between 1,862 square units and 1,900. It's exactly 38 less than, because 49 was one less than 50, 38 units less than when we figured out half of 100. So that's that one on there. Another one on there that's kind of tricky is you have a complex rectangle figure. So I want you to think about what we talked about, what perimeter actually means and what area actually means. Perimeter being the distance, linear, one-dimensional distance around the outside of a shape, and area, how many squares that you can count inside of the shape. That's it for today. We'll see you again soon.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Welcome back, family, fourth graders. We're on week 3, day number 5. Thank you for joining us again. It's Mr. Nick. If we look at our very first problem of today, we're looking again at area and perimeter. So it is asking us, draw and label a rectangle with an area of 32 square units and a perimeter of 36 square units. Use numbers or words to show that you are correct. So again, I think it makes sense maybe to add a context to this. So I'm going to change our numbers up again. We're going to try to make a 24 square foot cage for some chickens, and we want it to have a perimeter of 20 square feet. So I've got an area of 24 square feet and I want a perimeter of just 20 feet. So one dimensional for perimeter. I've got 20 feet of fence and I want to be able to have 24 square feet of space inside there for my chickens. So I'm going to start with some numbers. So if I do a cage that is 8 feet by 2 feet. Do I end up with a perimeter? That's 8 feet, 2 feet. Do I end up with a perimeter that's 20 square feet? 2 plus 8 is 10, plus another 2 is 12, plus another 8 is 20. So I've got a perimeter that's 20 square feet, but do I have an area that is 24 square feet? So if I draw this out, there's 2 there. I've got 1, 2, 3, 4, 5, 6, 7, 8 squares in that row, another 8 in this row, so I have 16 square feet. So I didn't make that category. So I need to try to make this a little bit bigger. So how else could I make this bigger? Maybe, let's try to get 24 a different way. So maybe I do 8 feet by 3 feet. So if I do 8 feet by 3 feet, I know right there I've got 8, 16, 24 square feet. So that's enough for my chickens. That's what I wanted for them to fit inside. But let me check my perimeter. So I made this category work, 24, but I want to make sure I have enough fencing for that. So there's 8 plus 3. If I go across here, 1, 2 units, 3 units, 4 units, 5 units, 6 units. Whoop. 1, 2, 3, 4, 5, 6, 7, 8 units. From there to there, there's 8 units or 8 feet and 3 feet. 8 plus 8 and 3 plus 3, 16 plus 6, that's too big. That's 22 feet. So that didn't work out. How else could I make an area of 24? What two numbers, what factors can I put together? If I try 6 by 4, (6 feet by 4 feet), there's 6, 12, 18, 24. So I've got the 24 square foot cage. Is that 20 feet gonna work? 6 by 4 is 10. 6 more, 16 plus 4 is 20. So now I've made both categories work. Your job is to be able to do the same thing, but you have an area of 32 square units and a perimeter for your cage of 36 square units. So your job is to try to figure out what different, and label the same way I did. Try out what things you can do. What is the way that you can make an area of 30 or 32 square feet and a perimeter of 36 square feet? Your next job for today is you've got a bulletin board, and you've seen your teachers set up bulletin boards, and you're gonna see it when we get to go back to school, a whole bunch of bulletin boards that say, "Welcome back." And so they're gonna be there before you get back, and they're gonna be covering up these bulletin boards with these sheets of paper. So their job in your problem today, they said you have, how can Shanice and Micah use yellow craft paper to cover a bulletin board? So they have a bulletin, I'm just gonna make a model for it. They have a bulletin board that is 11 feet by 7 feet. When they try to roll out their paper, it's only 1 yard long. So their paper is just 1 yard long. So they're gonna have to cover this. They could cover it this way, like that maybe, or I don't know how many times it's gonna take. They could cover it vertically or horizontally, but their paper is 1 yard long. So the little key for you when I want you to draw a model for this is 1 yard equals 3 feet. So show the 2 different ways in which Shanice and Micah can cover their bulletin board using their rolls of paper that are 1 yard long. So that's your second problem for the day. Your third problem for the day is just you get to pick which one of these would you rather have. So it says sell a batch of 30 cookies for 50 cents each with a cost to make of $8. or you could sell a batch of cookies or a batch of 30 cookies for $15 with a cost to make of $6. So what's going on here is you're not going to get to keep all that money. You're going to go to the store, buy all the ingredients that you need, put your mask on, put your gloves on, buy all your ingredients, and one batch is going to cost you $8 for all those ingredients, but you're going to sell those 30 cookies for 50 cents each, and you get to keep all the money minus that $8 that you spent already at the store. That's not your profit. And the other one is it costs you $6 for all the ingredients, but you're going to get to sell them for $15. So your goal is just to explain in words or numbers or pictures, which one of those would you rather have? Which one of those would you rather sell? That's it for today. We'll see you soon.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right, fourth graders, welcome back. It's Mr. Nick again. We're on week 4, day number 1. We open up today with a serious problem about feeding some kittens, or just a cat. So, Missy's mother owns a pet supply store. The directions on the small cans of cat food say, feed a cat 1 can of cat food each day for every 4 pounds of body weight. Missy started to make a table to help people know how much food to give each cat every single day. So she started out, she said, all right, I know that if the cat weighs 4 pounds, that's 1 can. If the cat weighs 8 pounds, that's 2 cans. Your job today for the cat food store is to figure out, or for the pet store to figure out, a chart for everybody so they know how many cans of cat food to feed everybody. So she did 4. If a cat weighs 8 pounds, she knew it was 2. I'm going to go to the next whole number and give that one to us. So if a cat weighs 12 pounds, it is going to be 3 cans of cat food. But what do we do in between some of these numbers? So, meaning if a cat doesn't weigh 8 pounds, then it doesn't get 2 cans of cat food. What am I going to do in these cases? So here's how this little pattern is going to work. And I'm going to draw it with the model. So if a cat weighs 4 pounds, they get 1 whole can. If they weigh 5 pounds, we know it's going to be 1 can and a little bit more. 6, 1 can and a little bit more. 7, 1 can and a little bit more. And then 8, they're getting 2 whole cans. So I'm going to partition this into fourths. And so on day 5, the cats are going to get 1 can and 1/4 of another can. On day 6, or not day 6, if they weigh 6 pounds, they're going to get 1 can and 2/4. But what is that fraction? What's another way to write that fraction? 2/4 is absolutely correct, or we can write it as 1/2. Day 7, 1 3/4, or not day 7, 7 pounds, and then 8. I said 2, but that would be just like filling up that one. So 2 full cans. On your own, go ahead and fill out the rest of the table. Your next problem for today is going to be, it just says compare fractions. So I'm not going to compare the fractions that you guys have. I made up some of my own fractions. So what we're going to do is look at a couple different ones. So if I look at, let's first start with 5/6 and 5/12. When I was in school, when most of your parents were in school, they would have said, find a common denominator. But they didn't have teachers like you did. So you're going to look at this a little bit differently. If I just look at the numerators, what's greater? Those are exactly the same, right? But what's more, sixths or twelfths? So this first one is like saying, if I have, these are based off the same whole, I have 5/6. The second one, same whole, I have 5/12. So which one of these is greater? Well, twelfths are, even though I have the same number of pieces, twelfths are much smaller than sixes. So 5/6 is greater. See if you can find a problem on your sheet where you can use that type of common numerator comparison way to figure out which one of those makes the most sense, or which one of those is greater or equal to one another. The next one let's try is, let's look at 4/7 and 3/8. What I want you to picture in your head right here to compare these is I want you to think about the fraction 1/2. So is one of these fractions less than 1/2? Is one of these fractions greater than 1/2? See if there's something on one of those fractions that are A, B, C, or D on your sheet where you can use this idea of comparing it to 1/2 to see what's greater or what's less than. Your last problem. So number 3, where it says whole number division. It's an open middle problem. All 3 of these parts need to be equivalent. So using the digits 1 through 9, and you can only use them one time each. How do I make it so that every one of these is equivalent? So I'm going to just try some stuff out. So if I do 4 and 2 here, 4 divided by 2 is 2. Now I need to put something here that's divided by, that it will be equivalent to 2. So let's say I could do 6 divided by 3, that equals 2. But now I need something here that is also equal to 2. And since I already used 6 and 3, that's not going to work because I can't use 2 another time. So your goal for this, keep trying numbers and think about what number cannot be your quotient for each one of these parts. What number can't be your quotient if we're going to have something here. On top of that, see if you can find multiple different ways to do this. So if you find it one way, is that the only way that you can find the solution to this? See if your parents can find another one. And thanks for tuning in today. We'll see you guys next time.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Good morning, IPS students. This is Mr. Schnipp from Christian Park Elementary coming at you again, and we're going to do some 5th grade math. Today we're going to multiply with fraction models. We're going to multiply with fraction models. Okay, so we're going to start out with the fraction 2/4 times 3/4. Okay, so when we draw with model, or when we do it with models, so what we're going to do is we're going to draw 1 unit because both of these fractions are less than 1. Okay, so this equals one whole. All right, and what we're going to do now is we're going to divide this 1 whole up into parts. Okay, so the first thing we're going to do with vertical lines, we're going to multiply, or we're going to divide this into fourths. Right, and we're going to shade 2/4. Okay, so we go this direction. We have 2/4 shaded, 1, 2. All right, and then we're going to multiply the 2/4 by 3/4. So now with horizontal lines, we're going to go the other direction and divide it into fourths. And we're going to shade 3/4 now. Okay, so there's 1/4, there's 2/4, and there's 3/4. Okay, so what we're going to do now to find our answers, we're going to look for the squares that are shaded with 2 colors. As you can see, I used, let me show you 3/4 there. So I used blue for my 3/4. And I use green for my 2/4, and we're going to look for the parts that are shaded together. All right, so I got 1, 2, 3, 4, 5, 6. Okay, so I've got 6 squares that are shaded with 2 colors. So my answer is going to be, my numerator is going to be 6. All right, now you do notice I have some other squares shaded, but there's not 2 colors in each. So we're not going to count those, but what we need to do is we need to count how many squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so our model shows that we have that 2/4 times 3/4 is 6/16. And if we multiply it across, 2 times 3 is 6, 4 times 4 is 16. All right, let's try a different problem. All right. Let's say our next problem is 2/3 times 5/6. All right. So we're going to draw our whole unit again. Okay, and this is 1 whole. So how many units am I going to divide this into vertically the first time? If you said 2/3, that's correct. So I'm going to use my green marker to show the 2/3. I'm going to shade it. And there's my 2/3. Then we'll use the blue marker to go the other direction with it, and we're going to do 5/6. So horizontally, we're going to divide it into how many sixths? 6th would be correct. So 1, 2, 3, 4, 1, 2, 3, 4, and 5. And it says shade 5 of the 6th. Okay, so we're going to go there's 1/6, 2/6, 3/6, 4/6, and 5/6. Okay, so once again, now I'm going to go back through and we're going to look for the boxes that have two colors in them. So we're looking for boxes that have both red and green, or blue and green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 boxes have both red and green. As you can look over here, those are all blue, and these down here are all green. Now we need to find out how many boxes there are all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So our answer is 10/18. Okay, so that is how you use fraction models to multiply fractions that are less than 1. You'll be doing this on day 1 and later in the week. I think on day 5, on day 5. I think this comes back again on day 5. So look for this at the end of the week also. Okay, the second thing we're going to do today is we're going to divide whole numbers with a decimal quotient. Okay, so dividing whole numbers with a decimal quotient. And we've done a similar activity to this several times, and where you had the boxes. And remember, and you can only use one number between 1 and 9 to go in those boxes. Okay, so I'm going to try a couple of examples for you, and we're going to see how this works. Okay, the first one I'm going to do is, I'm going to try 3 divided by 8. Okay, we're going to try 3 divided by 8. And think of this as, we've talked about how fractions are division problems also. So think of it also as being this way. Okay, so I'll put my 3 here and my 8 there. Okay, and then as I've talked to you guys about before, when we divide fractions, we always say top in, bottom out. Okay, so now we're going to divide. 8 cannot go into 3, right? Okay, so we have to add a 0 to it. And since that 3 is a whole number, we have to add a decimal point and a 0 and bring our decimal point up. 8 goes into 3 times. That is 24. Okay, and then we subtract. 8 doesn't go into 6. We've got to add another 0. 8 goes into 67 times. That's 56. That is 4. 8 can't go into 4, so let's come down here again. 8 goes into 45 times. So there's our answer, 375 thousandths. Does it fit there? We need to have a whole number, a number in the ones place, and a number in the tenths place. Okay, so keep this in mind. Okay, we're going to move this one over here. And I want you to see if you can figure out what types of problems that we have to put together to make this kind of work. Okay, let's try it. Let's try the second problem now. Let's try 4 divided by 3. Now remember, we can write this as a fraction to help you figure out what number goes where. And the top number goes on the inside, the bottom number goes on the outside. Okay, 3 does go into 4. Okay, it goes into 4 one time. 1 times 3 is 3. All right, we subtract. 3 can't go into 1. Okay, so just like we did the problem before, we have to add a decimal point and a 0 and bring that down. 3 goes into 10. Okay, 3 goes into 10 3 times. And don't forget, you got to bring your decimal point straight up too. 3 times 3 is 9. And we've got the same thing again. So we got to bring that 0 down. 3 goes into 10 3 times. At this point, we're going to see that we're going to get the same repeating pattern over and over. So it's going to be 1 3/10 repeating. Okay, now we've got our 4 divided by 3. Now we do have a whole number answer here. All right, we do have a number in the tenths place, but it doesn't stop there because we're going to get 3's over and over again. Okay, so we're getting closer. All All right, let's try one more and see if we can make this work right. See if we can make this work. Let's try 7 divided by 5. Okay, so 5 goes into 7 one time. That's 5. That's 2. Once again, 5 can't go into 2, so we have to add our 0 and bring it down. 7 goes into, or 5 goes into 20. Got excited there. 5 goes into 20 4 times. 5 times 4 is 20. Oh, we might have something here. So 7 divided by 5 equals 1 and 4/10. I think we've got it. We got a different number in each box. We stop at the tenths place. So I want you to look back and look at the types of numbers that you cannot use to get a whole number. And look at the way that we did this first one. Anytime you divide by a number greater than the dividend, you are not going to get a whole number. That's our lesson for today. Thank you for being with us this morning. We hope you have a good rest of the day. Just want you to know that we miss you, and we're getting close to the end of the school year, and enjoy your summer. Thank you.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Good morning, IPS 5th graders. This is Mr. Schnitt from Kirsten Park Elementary, and we're going to do some more 5th grade math today. I got to admit something to you. I made a mistake last week when I taught surface area. So the first thing that we're going to do today is I want to reteach surface area the correct way, and then we're going to play a game. I'm going to see if I can find someone from the crowd to come up and play a game with me. Okay, so last week we talked about surface area. Okay, and we talked about surface area with a rectangular prism. So I found this box, and I went through and I marked it off in the best that I could in inch units. All right, and remember when we talked about rectangular prisms, we said that they have 6 sides. They have a length, a width, and a height. Okay, so I'm going to go back and redo the formula and show you where I made my mistake. Okay, so we're going to use the initials SA to equal surface area. All right, and then since I said each area has 2 sides, okay, we're going to multiply what we come up with this box by 2. Okay, the first one that we're going to look for is we are going to look for length and width. Because when you talk about area, you have to multiply 2 sides together to get an area, and that's not what I had you do when we did this last time. So let's do length and width. So we take the top of our box and the bottom of our box. They both have a length and they both have a width. So if I go through and count my units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have our length times our width. So our length is 15 times the width, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so then we're going to take that length times the width and we're going to add it to the length and the height. All right, so again, our length is 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But our height goes from here to here, and our height is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have this side and we have this side, which takes us to our width and our height. All right, our width is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I miscounted, it's 11. And our height is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so now we're going to go through down here and we're going to use the order of operations and we're going to solve it. Okay, 15 times 11 is 165. I knew that in my head. Our length times our height is 135. And our width, and then our width times our height is 99. So then we're going to go, so now we've got 2 times those numbers. Okay, so now we're going to go through and we're going to add all these numbers together. So 165 plus 135 is 300 plus 99 equals 2. And 300 plus 99 is 399. You know, we can do this in our head because add one more to it, and that's 400. So 2 times 400 is 800. And we can subtract 2 off of there. So our answer is 798 units cubed. So that is how you find surface area. So it's a little bit more. Where I messed up last week is I had you do 2 times the length times the height times the width, and that was not finding surface area. So 798 units. So that is how you find the surface area. So if I were to wrap this piece of paper, I would need 798 square inches of wrapping paper. All right. Let me look out here in the crowd and see if I have any volunteers. Oh, Miss Cook. Miss Cook from Christian Park Elementary happens to be here, and she's going to play our game with us. A couple weeks ago, she got me on stage, and I played her game, and she beat me, and she really gloated in that. So we're going to try to see if I can beat her today. So our game, it's called the 100 game. Okay, so the first person that goes picks a number between 1 and 7. And then after that, every other person, as we take turns, after I pick a number between 1 and 7, Miss Cook will pick a number between 1 and 7, and we'll keep adding those together. And whoever gets to 100 first or over 100 loses. All right? 7.
5.
7 and 5 is?
I don't know. I teach 2nd grade, so that is 12?
12. 6. 12 plus 6 is 18.
Ooh. 5. 5 plus 18 is 23.
And I'm going to pick 7. 23 plus 7 is 30.
Okay, so let's 7. So 40 plus 30 plus 7 is 37.
And I'm going to pick 1. So 37 plus 1 is 38.
2. 38 plus 2 is 40.
It's going to take us forever to get to this one. I'm going to add 7 to it, and 40 plus 7 is 47.
47 plus 3 is 50.
We're halfway there. Now, if you might be a loser if you get exactly 100, so you don't want to get 100. We're going to start to have to get some strategy as we get closer to 100. We're going to go with 5. 50 plus 5 is 55.
I'm going to go with 7. So 55 plus 7 would be 62.
I'm going to go with 6. And what was it? 62, was that our number? 62 plus 6 is 68.
Okay, so 68 plus 3, 71.
I'm going to do 71 plus 4 and get 75. 3/4 of the way there.
Okay, so 75 plus 7 would be 82.
82 plus 4 would be 86.
86 plus 4, 90.
90. 90 plus 7 equals 97.
97 plus 1 is 98.
And 98 plus 1 is 99.
99 plus 1 is 100.
And we're even on our game. She won her game, I won my game. Thank you, Mrs. Cook. So that's a game that you can play at home with your friends, and you can do it with multiplication. There's all sorts of different things that you can do it with. That is our lesson for today. Have a great day, and stay safe. We miss you guys, and we will talk to you later.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Well, good morning, IPS students. This is Mr. Schnepp, and this is my last lesson that I'm going to be doing with you at the end of the school year here. One thing I thought I might do today is go over greatest common factor and least common multiple, because throughout the packets we've been doing a lot of things with fractions. We did some addition and subtraction with unlike denominators. So I want to review how we did least common multiple to find that. And sometimes our fractions asked us to simplify, and I want to use the greatest common factor for that. So let's start out with the greatest common factor, better known as GCF. Okay, so let's say we have a fraction that is 12/16, and your teacher asks you to write that in simplest terms, and you think, well, how am I going to do that? All right, well, an easy way is to find the greatest common factor of each number. So what I'm going to do is I'm going to make a couple of T-charts here, and I got a 1 and this is for the 12, so 1 and 12, 2 and 6, 3 and 4. Okay, 5 doesn't go anything, so 4. So once we start to repeat numbers, so I went 3 and 4. So once I repeat there, then I can stop right there. Then I go to the number 16. All right, and we go 1 and 16, 2 and 8, 3 times something doesn't equal 16, and 4 times 4 equals 16. So there we have double numbers, okay? So once we repeat or we get double numbers, then we're done, okay? So the factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 16 are 1, 2, 3, 4, 8, 16. So now we're going to find the greatest common factor. What is the largest number that both numbers have in common? And as I look through my list here, it looks like the number 4s are the greatest common factor. Okay, so what we're going to do then is we're going to take that 4, and since we're reducing or making smaller, we're going to divide. All right, so 12 divided by 4 and 16 divided by 4, because this is also making an equivalent fraction that is smaller than 12/16, so we have to divide the top and the bottom number by the same number. 12 divided by 4 equals 3, and 16 divided by 4 equals 4. So 12/16 in simplest form is 3/4. All right, let's try one more. Let's try 15/18. Let's try that one. Okay, so once again, we'll take 15 and we'll look for the factors of 15. So 1 and 15, 3 and 5, 4 doesn't go into it. So then once we get back here to the 5, we're repeating, so we don't have to go any further. So the factors of 15 are 1, 3, 5, and 15. All right, so now let's do the number 18. 1 and 18, 2 times 9, 3 times 6, 4 doesn't go into it, 5 doesn't go into it, so now we get back to the 6 again. Okay, so our factors of 18 would be 1, 2, 3, 6, 9, and 18. So we go look at our list. We have 2 1s. Those are common, but they're not the largest. This has a 2. The 15 doesn't have a 2. We've got 2 3s. So right now, that looks to be the winner. 5, it doesn't have 5 on both sides, and those numbers don't match. So what we're going to do then is we're going to divide each number by 3. 15 divided by 3 is 5. 18 divided by 3 is 6. So our answer is 5 6. So that's a very easy way for you to simplify a fraction without just trying to do it all in your head and that. So that's how you can use the greatest common factor to do that. All right, and we talked about this a couple weeks ago, but I want to do it one more time with you just as a review. And let's take the number 7/8 plus 2/3. Okay, so in this case, we're going to use the least common multiple of our two denominators to find a common denominator, because we cannot add fractions that have two different denominators. So we have to have an equivalent fraction for each of these with both the same denominator. So we'll start out with 3. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And then we're going to go for the number 8, 8, 16, 24, 32, 40, and I can stop there because I already knew that I had a 24 up here and a 24 here. Okay, so 24 is our common denominator. Now, when we divided or we reduced, we used division because we were going smaller. Now we got to make an equivalent fraction that's greater. So this time we're going to multiply. All right, so 3 times 8 equals 24. So if I multiply the bottom number by the 8, I have to multiply the top number by 8, and 2 times 8 is 16. All right, and then we come over here. 8 times 3 equals 24. 7 times 3 equals 21. So now we add 21 plus 16. 1 plus 6 is 7. 2 plus 1 is 3. And our denominator stays the same, so it's 37/24, and we could also simplify this this fraction also. If we were doing subtraction, same thing. You find a common denominator and then you subtract instead of add. So that's how we use the greatest common factor and the least common multiple. One, to add or subtract fractions to find an equivalent fraction that's greater. And to reduce fractions, we use the greatest common factor. All right, and we're going to wrap up here with the puzzle. Okay, so I got the numbers 8, 4, 2, 12, 4, and it has to equal 3. So what I have to do is I have to go through and use the signs plus, or add, subtract, multiply, and divide. And I got to put them in there. So I think what I'm going to do is I'm going to add here. I'm going to multiply here. I'm going to what did I put there? I'm going to subtract here, and I'm going to add here. Okay, so let's see how that works. Okay, order of operations. So we go through. So 8. We don't want to do this first because we've got to use our order of operations. So multiplication comes before that. So it's going to be 4 times 2 minus 12 plus 4. All right, so now let's do, so now we're down here. Now all we have left is addition and subtraction. So we have 16 minus 12 plus 4. Okay, so then we come down here with 4 plus 4, and we have 8. I need to find a number that goes with 3, so that doesn't work. So this is in the day 3 lesson, and I think there's a couple of them earlier in the week or earlier in the month that we did too. So your job is to go through and find and keep moving the signs around until you can find there's one way that it works to come up with the number 3. Well, that's all we have for today. This will be our last lesson that we'll be doing for the summer. Keep staying safe and enjoy the rest of your summer, and we will be looking forward to seeing you once school starts in the fall.
You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com, and be sure to follow us on Facebook. Here's what's coming up next.
Hi, my name is Mrs. Meadows. I have been teaching mathematics for 17 years. Now I'm at Great Minds, and I'm looking forward to teaching you the lessons in this course. Remember to let your teachers know that you are participating in this program. Today we will be covering Grade 6, Module 4, Lesson 5. We will learn how to represent and evaluate repeated multiplication problems using exponents. Today you will need a copy of your Lesson 5 workbook. If you don't have your workbook, it's fine. Just grab a piece of paper and a pencil. To make things a little bit easier, you might want to get a calculator as well. You can use a basic 4 function, your computer, a cell phone, or even scientific calculators. Let's begin. For our opening exercise, we are going to evaluate the following expressions. As you evaluate these expressions, I want you to think about the process that you use to arrive at your answers. Pause the video and we'll go over your answers in a moment. Let's review. How many of you counted on in order to evaluate your expression? Counting on sounds a little bit like this. You're starting at number 4, and then you're counting on 4 more each time. So 4, 5, 6, 7, 8, 9, 10, 11, 12. Did anyone use that as a strategy? Or maybe you counted by 9s. 9, 18, 27, 36, 45. Addition is a faster way of counting on. Did any of you use multiplication? Multiplication is a faster way to add numbers when the add-ins are the same. When we add 5 groups of 10, we use an abbreviation and a different notation called multiplication. 10 plus 10 plus 10 plus 10 plus 10 equals and can be written as 5 times 10. Is there another notation that we can use to abbreviate multiplying 5 groups of 10? We see that when we add 5 groups of 10, we write 5 times 10. But when we multiply 5 copies of 10, we write 10 to the 5th power. So multiplication by 5 in the context of addition corresponds exactly to the exponent 5 in the context of multiplication. Let's look at this a little bit closer. The 10 is called the base. The 5 is called the exponent. Why do you think we write exponents so carefully? The exponent is written using superscript so that it is not confused as a number in the ones place. Now we're going to pause the video and we're going to switch to the dot camera so that we can work on exercises 1 through 5 together. Now let's take a look at examples 1 through 5. Write each expression in exponential form for numbers 1 and 2, and write each expression in expanded form for numbers 3 through 5. Go ahead and pause the video and resume the video when you're ready to review the answers. Let's review our answers. 5 times 5 times 5 times 5 times 5, written in exponential form, will have a base of 5, and I have 1, 2, 3, 4, 5 fives, so my exponent will also be 5. 2 times 2 times 2 times 2, written in exponential form, will have a base of 2, and since I have 4 2's, 4 will be my exponent, and 2 to the 4th power is written in exponential form. Now let's write each expression in expanded form. 8 to the 3rd power will be written as 8 times 8 times 8. 10 to the 6th power will be written as 10 times 10 times 10 times 10 times 10 times 10. G to the 3rd power will be written as G times G times G. Now I want to make sure that the number of times that I've written 8 matches the exponent. I have 3 8s, 3, 4, 5, 6 10s, and I have 1, 2, 3 G's. Now go ahead and take your calculator and go back and evaluate numbers 1 through 4. Pause your video and we'll resume and go over the answers whenever you're ready. Let's review our answers. 5 to the 5th power is 3,125. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. 8 to the 3rd power is 512. 10 to the 6th power is 1 million. Now, take a look at number 5. What is the difference between G to the 3rd power and 3G? Well, remember from yesterday's lesson that 3G really means G plus G plus G. Or it can mean 3 times G. But G to the 3rd power will mean G times G times G. Now, let's go ahead and move on to numbers 6 through 8. Complete numbers 6 through 8, and when you're ready, we'll go over the answers. Let's review our answers. Write the expression in expanded form and then evaluate. 3 8/10 to the 4th power. So I'm going to write 3 8/10, 1, 2, 3, 4 times. When I evaluate that using my calculator, I will have an answer of 208 and 5,136 10,000. Write the expression in exponential form and then evaluate. 2 1/10 times 2 1/10. Well, I have 2 1/10 written twice, so 2 will be my exponent. When I multiply in the calculator 2 1/10 by 2 1/10, I will have an answer of 4 41/100. Write the expression in exponential form and then evaluate. So I have 75/100 as my base, and I have 75/100 written 3 times, so 3 will be my exponent. When you use a calculator, your answer should look like this. Now, taking a look at number 7 and number 8, the base of these two numbers can be written also as a fraction. Let's take a moment to pause the video and convert those decimals to fractions and evaluate. Leave your answer as a fraction and remember how to multiply fractions. Let's review your answers. 2 1/10 can also be written as a fraction, 21/10 times 21/10. 21/10 to the 2nd power. 21 squared is 441. 10 to the 2nd power is 100. 10 times 10. This is a fraction greater than 1, so I can write it as a mixed number as 4 41/100. 75/100 can be written as 3/4 as a fraction, and I'm going to write that 3 times. 3/4 to the 3rd power. Well, that means 3 times 3, which is 9, and 9 times 3, which is 27. 4 times 4 is 16, and 16 times 4 is 64. Now we'll move on to numbers 9 and 10. Go ahead and pause the video. And when you're ready to go over the answers, just resume. Let's go over our answers. Write the expression in exponential form and then evaluate. 1/2 times 1/2 times 1/2. Well, let's first write that in exponential form. I have 3 1/2, so 1/2 will be my base and 3 will be my exponent. 1 times 1 times 1, or 1 to the 3rd power is 1. 2 times 2 times 2 is 8. 2 to the third power is 8. Write the expression in expanded form and then evaluate. Well, the base has to be written 2 times. 2/3 times 2/3. Well, 2 times 2 is 4, and 3 times 3 is 9. There is a special name for numbers raised to the second power. When a number is raised to the second power, it is also called squared. Remember that in geometry, squares have the same dimensions, length and width. So take a look at this fraction. We can say 2/3 to the second power, but we can also use its special name and say 2/3 squared. Let's do some mental math. What is 5 squared? 25. What is the value of 7 squared? 49. What is the value of 8 squared? 64. What is the value of 1 squared? 1. I want you to think about a multiplication chart. Take a look at the multiplication chart. Where are the squares found on this multiplication chart? If you said on the diagonal, you are correct. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. And 12 squared is 144. Before we move on to our next set of exercises, I want to just go ahead and take a moment to talk about, before we get here, let's go back to this example. I do want to give you another special name. I can also use another special name if this is raised to the third power. When a number is raised to the third power, it is called cubed. Remember that in geometry, cubes have the same 3 dimensions, length, width, and height. So here I can say 1/2 to the third power, or I can say 1/2 cubed. Let's do some mental math again. What is the value of 1 cubed? That's 1 times 1 times 1, and that is 1. What is the value of 2 cubed? 2 times 2 times 2 is 8. What is the value of 3 cubed? 3 times 3 times 3 is 27. Now, let's review before we move on to our exercises. Take a look at this example. What does X represent? The X represents the factor that will be repeatedly multiplied by itself. What does the N represent? N represents the number of times X will be multiplied. Now take a look at the exercises 1 through 4. Go ahead and pause the video, and we will resume and go over the answers when you're ready. All right, let's go over our answers. Fill in the expressions for each row. For whole numbers and decimal bases, use a calculator to find the standard form of the number. For fraction bases, leave your answer as a fraction. So what's great about this is that we have 3 different forms: exponential form, expanded form, and standard form. And one example has already been done for us. In exponential form, we have 3 to the 2nd power. We just learned a new name. We could also say 3 squared. In expanded form, 3 squared would be written as 3 times 3. And standard form is really how we evaluated the other expressions earlier. And so 3 times 3, or 3 squared, is 9. Now let's take a look at the next row. 2 times 2 times 2 times 2 times 2 times 2 would be written as a base of 2 and an exponent of 6. I know that my exponent is 6 because 2 is written 6 times. So now let's evaluate this expression and write it in standard form. Well, 2 to the 6th power is 64. 4 to the 5th power, written in expanded form, will be 4 times 4 times 4 times 4 times 4. I know that I'm correct because I have 4 written 5 times. Now 4 to the 5th power in standard form is 1024. 3/4 times 3/4. Well, I'm going to write 3/4 as my base, and since it's written twice, I'm going to use 2 as my exponent. Remember that this is 3/4 to the 2nd power, or I can use a special name of 3/4 squared. Now I'm going to write this in standard form. 3 times 3 is 9, and 4 times 4 is 16. Now I have 1 5/10 times 1 5/10. Well, 1 5/10 will be my base, and because this is written twice, 2 will be my exponent. 1 5/10 times 1 5/10 is 2 25/100. Write 5 cubed in all 3 forms: exponential form, expanded form, and standard form. Here goes that special name, cubed. I have to remember that 5 is going to be my base and 3 is going to be my exponent. That is exponential form. Anything raised to the 3rd power has a special name, and that's cubed. Now let's write that in expanded form. 5 times 5 times 5. The 3 is going to tell me how many times I'm going to write down 5, or multiply 5 by itself. Now let's write this in standard form. 5 times 5 is 25, and 25 times 5 is 125. Write 14 7/10 squared in all 3 forms. Well, let's start off with exponential form. 14 7/10 squared. Remember that we can say 14 7/10 to the 2nd power, but we have this special name, squared. Now let's write that in expanded form. 14 7/10 times 14 7/10. I have to write it twice. 14 7/10 times 14 7/10 equals 216 9/100. This is written in standard form. Our last question says, one student thought 2 to the 3rd power was equal to 6. What mistake do you think he made, and how would you help him fix his mistake? Well, this happens to be a common mistake. I hope that you understand that he multiplied the base times the exponent. And we know that you can never multiply the base times the exponent in order to write this in standard form or in order to evaluate this. So 2 to the 3rd power actually means 2 times 2 times 2. 2 times 2 is 4, and 4 times 2 is 8. We use multiplication as a quicker way to do repeated addition if the addends are the same. We use exponents as a quicker way to multiply if the factors are the same. That's it for today. I'm Mrs. Meadows, and remember to let your teachers know that you're hard at work. And I hope to see you tomorrow.
Look around. Listen. We're moving to a new beat. A colorful symphony, each note made more beautiful by the next. We are driven by talent in the classroom, in each school, that recognizes the potential in every student and knows the opportunity to achieve is not an option, it's expected. We are not alone. We stand among giants, eager to help, eager to give back and build bonds to last generations. We are part of a city fueled by grit, strength, and determination. Racing toward a future full of potential, where hard work really does pay off. When one succeeds, we all succeed. We're innovative, we're industrious, we're imaginative. We are your Indianapolis Public Schools, and we're stronger together.
Hi, I'm Alicia Johnson. We all know the importance of keeping students engaged in learning during this unprecedented time. In addition to receiving IPS home learning packets, it's crucial for students to see and hear from the teachers they know and love. Through our partnership with Circle City Broadcasting, IPS teachers in grades K through 8 cover everything from reading to math in weekly lessons on MyINDY-TV. Together, we are making education accessible for everyone. For the schedule, visit wishtv.com/IPS.
When I was your age, I was just like you, fascinated by stars. But now I get to search for life in the universe. And who knows, maybe life is looking for us too.
So we're like aliens to them?
Yeah. Does anyone want to be a scientist now?
I do.
Awesome. We need more girls in STEM.
Maybe we can find aliens.
For as long as we've existed, Boys and Girls Clubs has always been about coming together to support the families of our communities and do whatever it takes to give every kid a chance at a great future. But we're going through a challenging time right now. And while we may not all be able to come together in the same physical ways, in other ways, we're coming together like never before. Because that's what whatever it takes to build great futures means. It means providing a safe place to go for children whose parents are on the front lines battling the virus. It means providing millions of meals for kids who previously relied on their school or a meal program, which are now shut down. And it's about harnessing the power of technology to keep kids moving forward with their education. So yeah, whatever it takes to build great futures may mean something different right now. But whatever it is, that's exactly what we're going to keep doing.
I think I need to call in sick.
Why? What's wrong?
My throat is sore, dizzy, runny nose.
It sounds like nasopharyngitis.
More than a dozen surprisingly specialized education models to choose from. Explore them all online. Yeah, that's IPS.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right, hello 7th graders, IPS families. This is Sarah Couch, and I am coming to you from the IPS boardroom to present Unit 6, Lesson 7, and we're going to continue reasoning about solving equations, but now, instead of using tape diagrams, we're going to figure out what these cool things are, and we're going to talk through them together. So go ahead and get your packet out. This is Unit 6, Lesson 7. And we are at 7.1. We're looking at these two things called hanger diagrams. So if you guys have, hang up your clothes, you can recognize kind of the shape they're going for a hanger. And in the two diagrams, all the triangles weigh the same and all the squares weigh the same. For each diagram, come up with one thing that must be true, one thing that could be true, and then one thing that cannot possibly be true. All right, so I just want to take a look at these pictures really quickly with you for a second. We have this one on the left. We have a triangle on the left-hand side. We have a square over here. I added the colors just to help you see them a little bit easier. So red is down here, yellow is over here. And you can see maybe that the triangle's hanging lower than the square. You could probably see it a little more clearly on your paper. But you can see that the triangle is hanging lower than the square. I want you to keep that thought. And then we'll look at this one. So if you look at the middle here, it is perfect right angles, meaning that this side and this side are exactly perpendicular, okay, meaning they are even. They're the same height. So we have a triangle over here, and then we have 1, 2, 3 squares and a circle. Okay, so first thing we have to do is one thing that must be true. It has to be, and we can only think about it in the sense of these pictures. So you could think of this being used as a symbol. So this would mean that you're equal, right? Because both of them have the same weight or value on each side. So when they're perpendicular like this, when they're even, that means they're going to be equal. Okay. Now this one, see how this guy's heavier, right? And if you remember your symbols, greater than, less than, or equal to, you remember the alligator, he always likes to eat the bigger meal. And so he would be faced in this direction, right? Because he wants that bigger, heavier, tastier triangle, not this wimpy little square. All right, so one thing that must be true, you could think of a couple things, but I'm going to go with this one, that the triangle is greater than the square. And I can look over here and confirm that, right? Because this triangle is equal to 1, 2, 3 squares at least. So this triangle definitely has to be more than this square. All right, one thing that could be true. I would have to look at this a bit more to tell you whether or not that these are exactly true. But it's a theory that I have right now because they are the same heights on the picture. So I'm going to say that the triangle could be equal to, we'll say 3 squares plus a circle. Does that look good to you? Alrighty, so now one thing that cannot possibly be true. So something I know not to be true is the opposite of this, the fact that the triangle would be less than the square. That cannot be true because our pictures state that this one is heavier, so this could not possibly be true. All right, so these visuals are going to help us solve the rest of these problems, so stick with me and we're going to start on 7.2 in just a moment. All right, guys, so now we're going to do 7.2, which is called hanger and equation matching. It says on each balanced hanger, figures with the same letter have the same weight. So this statement tells you two things. It tells you that all of these hangers are balanced, meaning that they are equal to each other. All right, so that's good to remember. And then it's also telling you that the letters, like all the W's here, they're the same. All the Z's here are the same, X's same, Y are same for each of their own equations. Okay, so it's just letting you know that those variables are equal so that you know that to solve the problem. At the bottom, so you see your diagrams. I did the best I could with what I had to represent them up here. And then we have our equations. We're going to match the picture with the equation, and then we're going to fill in the missing letter. All right, that's how we're going to match them. And there's two more things at the bottom. It says to match the equation and then complete it with writing the letter in the empty box and then find the solution for each equation. So first I'm going to help you match these and then I'm going to reset the board and we're going to solve some of them together. I might give some for you to do, so pay close attention to what I do because the steps are really going to be similar. All right, so let's look at this first equation. So I'm going to look at the diagrams and then I'm going to probably, hopefully, find the equation that represents that. So if you look on here, we have this equals 1, okay, or that's the square on your picture. I didn't have square magnets, so we had to use yellow circles. So flexibility, right? It's important. So we have 1, 2, 3, 4, 5, 6, 7 represented over here. I'm going to write that down there so I don't have to remember it. And then we have WWW. We do not know what those represent. And then we have a 1 right here. So let's look down here and see if we have anything that we recognize. Obviously, we won't see the letters, so I'll think of either this 7 or this 1 that we have. So that doesn't have it. No, no. This one has a 7 in it. So we have 7 equal, right? So I'm not 100% sure that it's connected, so let's continue through the problem and see if it matches the other things. So we have 3 of our blank, our variable, which we know is going to be one of these letters. So let's see if we have 3 of these W's. We have 1, 2, 3. We do. So then we're just going to add the 1 to those 3, and we have that represented right here. So in fact, A is this problem down here, and then that means this letter is going to go in this bottom box. All right? So we have this next one to look at. We have Z, 2 Z's, and then we have 1, 2, 3 squares on the left, and that is equal to 1, 2, 3, 4, 5 squares on the right. So we have 5, and we have 3 circles. Okay, so I'm going to do the same thing. I'm going to say, you know, a 3 or a 5. I'm going to look out for those. So if I start up at the top, I already noticed that I have a 3 and a 5 in here. Now I need to see if it represents what I'm really looking for. So I have 2 plus 2 times the variable, so 2 of whatever letter we're going to use. So I need 2 of these circles, and I do. And then we add the 3 to those 2 circles. So we have the 2 circles, and then we have 1, 2, 3 added to it in the picture. So that all lines up. Now this all has to equal 5 in order for these to be together. So 1, 2, 3, 4, 5 is equal to the same. So this does match. That means we have the Z right there. This one, this blue circle represents an X. We have 1, 2, 3 of the X's over here, right? We can write it like that, same thing. And then we have 2 1s, right? And we're going to add those together. And then what do we have here? We have 3 holes. So we can already look down here and kind of see, we don't have a 6 anywhere in our equation on this picture. So we're going to be here, and then that means we're going to have an X. Oh, and then sorry, that equals 3. I just forgot to write that beforehand. You don't have to write it down. That was my bad. Moving on. This next one, obviously we have dwindled out our chances. We have gotten A taken care of, B taken care of, C taken care of. So that leaves no other option but for D to be represented by this equation. But let's double check to make sure it's true. This says 6 equals 2y plus 3. That means we have 1, 2, 3, 4, 5, 6 individual boxes right here, which is true. And that is equal to 2 of our variables. And then we're adding the 3 there. So does that match? Yes. So these are all good to go. Go ahead and take a second and write those variables in your boxes, and then we're going to look at finding the solution for each of these equations just up next. All right, guys, we're doing the second question under 7.2. We just matched these up with their equations. I wrote them down here for us, and now we're going to utilize the pictures to help us solve the equation. Okay, so we have represented here 7 singular units equal to 3 W's, the W's we don't know, and then plus an extra singular unit. So now, the point is we have to keep this equal, okay? So we have to do the same thing to both sides, otherwise they'll get uneven, and then the sentence won't be true anymore. So what can we do to this side and this side? The first thing we can do is take care of any units that we have similar. So this guy matches this one. Now we only have one of them, so that means we can only take one away from both sides, and that is represented like this. All right, so this is 0, so this cancels, and then this goes down to 6, which equals 3W. Now, these are not similar, so they cannot cancel each other out on both sides, so we have to think about this a little bit differently. I know that I have 3 of these W's, and they have to be equal in value. So that means that these 6 individual pieces have to be divided equally among these 3 W's. So this is what I'm going to do. 1, 1, 1, and then 2, 2, 2. Okay, so what I did was for each W, I gave a 1. Oh, sorry. And then I had some left over, so I did it again. Okay, so that means that this W, in fact, equals the same as 2 singular units. Okay, and that can be reassured by the fact that we can divide this 3W by 3 to make it a 1W. And then we have to also divide by 3 on that side, making that W 2, W equal 2. All right, hangers are pretty neat. They help us visualize things, and sometimes it's hard to do that. So this gives us a good way to do that. Okay, so we have 2Z plus 3 equals 5. So obviously similar things. We have these two, 1, 2, 3 groups, right? Canceled each other out, meaning we did the same thing as subtracting 3 to both sides. This is 0, canceled each other out. This is not 0, we have 2 left over. And then that means we still have the 2Z here, okay, represented here. So I'm going to do the same thing again. I'm going to put 1 here, put 1 here. Do I have any left? No. So that means that the Z is equal to the same value as one of these units right here. Alrighty. I'm going to leave you two. I'm going to leave you to do the rest of these two together. Because I believe that with all of the work that we've been doing together, I think the understanding is there, and you can utilize these pictures. So look for similarities and then divide evenly as much as you can. All right, and if one whole doesn't divide right into here, try splitting it in half, all right, and see how that works for you. Ask your teacher for help if you need it. Please reach out to us. We miss you. We're so close to summer, and we're so excited to be able to bring this to you. And please be safe and enjoy your summer, and I'll see you later. All right, guys. So now we're looking at 7.3. But here's the deal. I'm going to do A and D with you. So the first one and the last one, and then you guys are going to do B and C, the two in the middle. Okay, so if you look right here, I'm going to do this one and this one for you, and then you guys are going to utilize what we did together to help you solve those other two. So we have 3 things to do. It first says, here are some balanced hangers where each piece is labeled with its weight. For each diagram, we 1, write an equation, 2, explain how to figure out the weight of a piece labeled with a letter by reasoning about the diagram, and then the second one, we do it by reasoning about the equation. So I'm going to be doing both of those things simultaneously because I'm going to be utilizing the picture and then showing you what that looks like on the diagram. Okay, so I would encourage you to draw the picture with me and to follow along very closely, okay? So first, we notice that this is a whole block, and it says the number 7 in it on your picture, but what that actually represents is 7 1 units. Okay, so 7 individual units, and we're going to represent this on the board utilizing this color circle. All right, and then the X represents these 3 blue circles here, 3 X's, and then we have a singular unit right here. So when we remember that these are balanced, that means they are equal, meaning that this 7 is equal to this amount of the 1, 2, 3 X's plus this individual unit. Okay, so now we're going to solve it. We're going to use it, reasoning our picture and our equation. So first thing, we look for these similarities, right? So what do we have similar between the left and the right-hand side? Something that we could eliminate from both sides equally. You're right, this one unit right here. So we can take this guy out. We can take this guy out. And then that is represented in our picture by subtracting 1 to both sides, right? And I can't do more than 1 because I didn't have more similar yellows on this side in order to be able to evenly take them out. So we have 7 minus 1, which is 8. We drop that 3x and the equal sign. And then this guy equals 0, so we can just eliminate him. So that means that we have, oh, you know what? My bad. I was adding for some reason. So this is 7 minus 8, which is 6. So that makes a lot more sense. 6 equals 3x. Now, just like we did with the last one, we think about how we're going to split these 6 now evenly up into our x's. So I could think about it like this. I could draw a circle to represent each x, and I could move my, like this, right? And then I have some left over, so then I evenly distribute them. Whoop, again. All right, and then our answer is going to be what 1x equals. This guy right here. Not all of them together, but 1x. All right, and then that's the same as dividing by 3 to both sides. And then that x equals 2, right? Because that represents the same as 2 singular units. Okay, guys, so now we're going to look at D. And you might have noticed, but I made a few adjustments to the picture because I realized that something was up with it. And I actually added another W and fixed my picture, so we're good to go for D now. So if you look, this is equal to a W, or the triangle on your picture, and we have 1, 2, 3, 4 of them on the left. And then you have the square here that says 3 halves. And then you have the one on the right that says 17 halves. So that means we're not necessarily going to be dealing in whole units. So this is our red circle, and it's going to represent 1/2. So that's what that looks like. We have 3 1/2 units to represent our 3 halves here. And then for 17 halves, we have 17 of these babies over here. So first thing we got to do is write the equation to match the picture. So we're going to start from the left. We have 1, 2, 3, 4 of our W's. And they're of the same value, so we can combine them all together. And then we add that 3 halves right there. And then that is equal, right, because this is balanced, so that means these are equal to each other, 17 halves on the right. Okay, so just like we did over here, we first found the similar values or the similar pictures on both sides. So we have 3 units over here, and then we have 3 units over here. That means we can evenly take out both units and still leave it balanced. So we took 3 1/2, both from each side. So that means we represent it like this. All right, these two cancel each other out. And then we have the 4W, which is equal to 17 halves minus 32 halves, which is the same as saying 17 minus 3 over 1/2, which is 14 halves. And you can even count it and double check if you want to. 1. Okay. I always want to double check myself too, because teachers are not always right. We make mistakes too. So it's always good to double check yourself. So now we're out this guy, we're out this guy, and now we're at 14 halves. So now we cannot simply cancel each other out. So now what we have to do is we have to think of these 4 W's and how they're the same value. So these have to be evenly distributed between the 4 W's. So I'm going to put 1, 1, 1, 1, meaning I'm evenly distributing, giving each one the same amount as long as I can until I run out. Okay, so I have 3 halves in each circle, but then I just have 2 halves left over. Okay, so 2 halves, which equals 1, right? Okay, so now I got to think, how can I split these up in order to fit them evenly, right? Because these have to go evenly into here, so I got to do something. So do I put them together and make a 1? If I only have one thing, I can't split it evenly. So what I actually have to do is I have to divide these up even more. So I'm going to take my halves, and then I'm going to split them in half, right? And so that means I have this half split into 2 parts, and this half split into 2 parts, okay? I'm gonna go ahead and put these down. We're just gonna use pictures now. So when I have 1/2 split into 2, what I actually have is 2 1/4 pieces. I have 1/4 here, 1/4 here, and then the same on this circle. Because, hold on, 2/2 is the same as saying 4/4, right? And I have 1/4, 2/4, 3/4, 4/4 here. So now that I have 4 of the same amount of things, I can evenly distribute them, right? So 1/4 here, 1/4 here, 1/4 here, 1/4 here. Okay, so this is 1/2, 2/2, 3/2 plus 1/4 for each square. So that means that W, right, if we divided this by 4, we divided this by 4 over 1, okay? It looks like that mathematically, but I actually like thinking about it in the visual sense because it makes much more sense to me to think about it that way. So if I have this 1/4, I need to break these up into 4 pieces. And how I can do that easily is I can just multiply the top and the bottom by 2, and that gives me, what is it, 6/4? And then I'm adding the 4/4, so that actually gives me W equal 7/4. And I'm gonna double check myself on my work. Yep, that makes sense to me. So each of these is going to equal 7/4. That's gonna add together to make simplified out to 14/2, and then you add the 3/2 back, and then that's, you know, putting the picture back together. So I know this gets a little messy, so really try and utilize those visuals when you do it to help you solve B and C, and then make sure to read the lesson summary at the end to help kind of bring together all of this information. I'll see you again for lesson 8, so stick around.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right, welcome back, 7th graders. We're actually going to be working on math, Unit 6, Lesson 8, and we're going to continue reasoning utilizing some hangers. But first, looking at 8.1, it wants us to select all the expressions equivalent to 2 times the quantity x plus 3. So I went ahead and drew this over here, and I'm just going to draw arrows if I think that they're equal to that value. So let's think about this. So 1 is 2 in this little circle. This dot means multiply, right? So 2 multiplied by the quantity x plus 3. Well, that's saying the exact same thing. We just took out a dot because we don't really need it. So yes, number 1 is equivalent. Now we have number 2. We have x plus 3, the quantity, times 2. Well, if you remember, with multiplication, that order doesn't really matter. The 2 could go before, the 2 could go after. If they're multiplied together, the order does not matter here. So this is also equivalent, because you see, if I just flip the 2 from the front to the back, it's the same problem. Now let's look at 3. 3, we have to think about, because there's not a, you know, a quantity in it. We have 2x plus 2 times 3. Or 2 times x plus 2 times 3. So I want to think about this and try and stretch this out using the distributive property. So I multiply the 2 here, then I multiply the 2 here, giving me 2x plus 3 times 2, or 6, but I'll write it like that. And that is actually the exact same thing as number 3. So let's look at 4. We have 2x plus 3. Now, they multiplied out the x, but if it were true, if it were similar, the 2 would also need to be multiplied by this 3. So this one is not equivalent. Now let's think about this one. We have the quantity 2 times x, so that's fine, plus 3. We know that we still need to multiply that 2 by the 3, so that's not equivalent. And then we have this guy. We have the quantity 2 plus x, right? And then that whole quantity is multiplied by 3. Now if we distributed this out, just to double check, we would get 6, or 2 times 3, plus the quantity 3x. Well, we don't want 3x, we want 2x's, so this one is not equivalent at all. So we're going to utilize all of the information that we've been working on to help us move on to 8.2 and 8.3. So stick with me and we're going to do some of it together. All right, guys, so we're looking at 8.2, and 8.2 is called either or. Number 1 says explain why either of these equations could represent this hanger. So this is the hanger we have. Look over here on the left, we have a big block represented by the number 14. Then we have 2 x's and 2 blocks of 3. So we have 2 equations at the bottom. 14 equals 2 times the quantity x plus 3, or 14 equals 2x plus 6. And we have to reason, utilizing the hanger, why these equations could represent the same picture. So let's think about this first one. We have the 14 already, so we don't need to do anything with that. Now we have 2 times the quantity x plus 3. So that means that these have to be the same value 2 times in the picture. Okay, so let's think. We have 2 x's, cool, we have 2 3's, but how do we represent that like the picture? So we could look at the quantity inside. We have x plus 3. Well, we have an x plus 3 right here, and then we have an x plus 3 right here. Now, those are 2 of the same quantities, x plus 3, right? And that is still equal to 14. So that is the great way that you can reason that one. Now let's think about this one, right? Because I don't see a 6 in my picture, so we have to think about it a little bit differently. So let me get another marker to represent this one. Use brown. So we have 14 equals 2x plus 6. We don't have a quantity, so we're thinking about these individually, okay? So we have 2 x's, right? So we have this guy here, this guy here, and then what they do is they combine these 2 3's together to make 6, right? So then we have these 2 together, 2x, and then we're adding that 6 value onto the other side. Okay, so I want you to find the weight of one circle. So this x, right? So we're finding the value of x. Okay, so you can use either equation, but I want you to do this on your own because I think you can do it, especially utilizing the picture. Make sure you're eliminating things that are similar and then breaking things up evenly so you know the value of one of the variables in the picture. All right, so we have over here on the left, we have 2 times the quantity x plus 5, and that is equal to 16. So the first thing I want to do is I want to look at my picture and see what I can do with that. So I look for my similarities, the things that are similar in unit, right? We only have the x's on the left, but we do have digits, right? And if these were split up, they'd be 5 singular units. This would be 5 singular units. This would be 16 singular units, but they're of the same type of value. So we're going to take the 5 out of here and 5 out of here, but that means we also have to subtract 5 on each side as well. Okay, so you could multiply this out, make it 2x plus 10, right, and then add 16. That's the same thing we're doing over here. We're subtracting 5 twice, which is the same as subtracting 10. All right, so these cancel each other out, and now we have 2x, which is equal to 16 minus 10, which is 6. Okay, so then we have to think, how many of these individual units can I evenly distribute into each x? Because I have 2 x's here that I distribute with. So I have 1, 1, 2, 2, 3, 3. So 1, 2, 3, 4, 5, 6, and they're split up evenly, right? Or I just divide it like this on my equation, leaving my x to be 6 divided by 2, which is represented here, which equals 3. We miss you. We hope you have a great summer and stay safe. Have a good day.
You've been watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. MyIPS airs weekday mornings from 8 a.m. to 10 a.m. For more information, special announcements, and the weekly program schedule, go to wishtv.com. You can also follow us on Facebook.
Look around. Listen. We're moving to a new beat. A colorful symphony, each note made more beautiful by the next. We are driven by talent in the classroom, in each school, that recognizes the potential in every student and knows the opportunity to achieve is not an option, it's expected. We are not alone. We stand among giants, eager to help, eager to give back and build bonds to last generations. We are part of a city fueled by grit, strength, and determination. Racing toward a future full of potential, where hard work really does pay off. When one succeeds, we all succeed. We're innovative, we're industrious, we're imaginative. We are your Indianapolis Public Schools, and we're stronger together.